Hello everyone, welcome to my channel. Now in this video I am going to discuss a few methods to solve such simple circuits. I'll be discussing three methods. First, the conventional method, the Kirchhoff rule, and then I'll be using two shortcut techniques. So please watch this video completely. Suppose the question is to find the current flowing through this 2 ohm resistor. Okay, so we'll be using three methods. So first, the conventional method. So the task is to find the current through this 2 ohm. So this is, suppose I current flowing through this, I1 going in this direction, I is the current through 2 ohm, I1 going in this direction. So current through 4 ohm will be I minus I1. Okay, so now I have two unknowns, I and I1. So two unknowns means I need to have two equations. Two equations means I need to take two loops. Okay, so if I take this loop using Kirchhoff voltage law, so since I am moving from this side to this side, current is flowing from high potential to low potential. So there is a loss in potential. So this is minus 2I. So again, current is flowing in this direction. I am also going in this direction. So high potential to low potential loss. So this is minus 2I1. Then from this part, I am moving from this direction to this direction. This is low potential, this is high potential. So there is a gain in potential. How much? 20 volts. So plus 20. So total potential drop across a closed loop is 0. So this is equal to 0. Okay. Now if I take this loop, this is again current is flowing in this direction. So current flows from high potential to low potential. So there is a loss. So this is minus, loss means minus sign, minus 4I minus I1. Then I'm taking this path. So this is high potential, this is low potential. So high to low there is a loss. So this is minus 10, and this is current is flowing in this direction. So current flows from high potential, low potential. I am taking this path. So that means I am moving from low potential to high potential. So there is a gain. So this is plus 2I1. This is equal to 0. Now this on simplification, this becomes minus 4I. So this is plus 4I1 minus 10 plus 2I1. This is equal to 0. So this is 4I1, this is 2I1. So this can be written as 6I1. Okay. Now if I multiply this equation by 2, I will get minus 4I minus 4I1 plus 40 is equal to 0. Okay. So now if I subtract these two equations, so this is plus, this is positive, this is negative. So this cancels out. So this is 10I1. This goes to the other side is equal to 50. That gives I1 is equal to 5 ampere. So that means current flowing through this 2 ohm resistor is 5 ampere. Okay. So this is the normal conventional method. Now let us solve this using two techniques or two shortcut. You can call it shortcut techniques or normal techniques. Across this the potential difference is 20 volt, across this the potential difference is 10 volt. So that means if this is 0, this is plus 10, if this is 0, this is plus 20. So that means I can take this point to be at 0 volt. Okay. Now this is a conducting wire. So this conducting wire doesn't have any resistance. So there is no potential drop. So that means if this point is at 20 volt, this point will also be at 20 volt. Okay. Now similarly this is 10 volt. So this point will be at 10 volt. Now I need to find the current across this resistor. I don't know the potential at this terminal. So let it be V. Okay. So this is V, 0 volt, 20 volt, 10 volt. Okay. Now in this method 2, what you need to do, you assume this potential to be, either you assume this potential to be lowest or you assume this potential to be the highest. Okay. As compared to the other near points, near junctions. Okay. Now if this point has lowest potential, that means all the current will be flowing in this direction and the total current meeting at this point will be equal to 0. That is the junction rule. So if I am assuming this potential to be lowest, that means current is flowing in this direction. How much current will flow in this direction? Potential difference will be 20. How much will be the potential difference? It will be 20 minus V divided by resistance is 2 ohm. So this is the current flowing in this direction. Current flowing in this direction will be 10 minus V divided by 4. Current flowing in this direction will be 0 minus V divided by 2 is equal to 0. This is total current meeting at this point is equal to 0. Okay. Now this on if I take LCM, so this is 40 minus 2V plus 10 minus V, then this is minus 2V is equal to 0. So this is 50, 2V, V, 2V. This is minus 5V, this goes to the other side. So this is 5V is equal to 50, or V is equal to 10 volt. Okay, so that means this point is at potential 10 volt. Now if this is 10 volt, this is 0, so potential difference is 10 volt. Resistance is 2 ohm, so how much will be the current? Current will be potential difference across these two terminals divided by resistance 2, so that is equal to 5 ampere. So this is same as the previous answer. So current flowing through this is 5 ampere. So this is method 2. Now let's see method 3. Now in method 3, this circuit, it needs to be redrawn as okay. So now see, this is called principle of superposition. That is, this circuit is a superposition of these two circuits. Okay, that is current. See, that is current flowing through this 2 ohm. 20 volt potential is sending a current through this 2 ohm, and this 10 volt potential is also sending current through 2 ohm. So current that is sent by each cell is independent of presence of other cell. So this is principle of superposition. How do you do this? Means how do we apply this principle of superposition? Like in this circuit, you short circuit this cell and you redraw the circuit. So short circuiting this cell will give this circuit. Okay, then you short circuit this cell and then redraw the circuit, you will get this circuit. Okay, now superposition of these two circuits will give this circuit. Okay, so let us now find the current that is flowing as a result of this 20 volt cell. So now this 4 ohm and 2 ohm, they are in parallel, and this combination is in series with this 2 ohm resistor. So this is 4 ohm and 2 ohm, they are in parallel, means 4 into 2 divided by 4 plus 2. So this is 4 by 3. Okay, so this equivalent resistance is 4 by 3. So this is in series with this 2 ohm. So this is 2 plus 4 by 3 total resistance. So this is equal to 10 by 3 ohm. So 10 by 3 ohm is the total resistance of the circuit. Now this is potential source is 20 volt. So that current, if I is the current flowing through this is the total resistance. So that gives I is equal to 20 divided by 10 by 3. So that is equal to 6 ampere. So that means the total current which is flowing from this cell is 6 ampere. So through this resistance 6 ampere current is flowing. Okay, now this 6 ampere current is getting divided into these two resistors. Okay, now they are in parallel. Okay, so now since they are in parallel, and how much is the potential drop across this part? It is 12 volt. This is 20. Okay, 12 volt is dropped across here. So if 12 volt is dropped across this 2 ohm resistor, that means across this the potential drop will be how much? This is total is 20, 12 is dropped, so left is 8. So across this the potential drop will be 8. So if 8 is the potential drop, that means the current flowing through this will be how much? 2 ampere. Okay, now if 2 ampere current is flowing through this, that means 4 ampere current is flowing through this. Okay, see, this is 20. These two are in parallel and it is in series with this. So this circuit, it can be redrawn as, this is 2 ohm, this is 4 ohm, This is 4 ohm, this is 2 ohm, and this is 2 ohm. This is 20. Okay, so this potential is drop. One part is drop across this point, one rest is drop across this point. Okay, so since this is 6 ampere, so that means potential drop across this part is 12. So if this is 12, this is 20, so this will be 8. So I hope now you are able to understand why the current is 2 ampere, why the current is 4 ampere. Okay, so now that means current flowing through this 2 ohm resistor is 4 ampere. Current flowing through this 2 ohm resistor is 4 ampere. Now similarly, you can apply this concept in this circuit, and you'll find that current flowing through this is 1 ampere. Okay, 2 ohm resistor. So that means again the total current I have already solved it. You can also use this technique to find the current through this 2 ohm resistor, and you'll find that it is 1 ampere. So the total current is again flowing through this 2 ohm resistor is 5 ampere. We are getting the same result using the 3 different methods. So whichever method is convenient to you, you can use this method in your examination. Not in board examination. Board examination, it might be expected that you use this Kirchhoff rule, but in your entrance you can use any one of the techniques, whichever is comfortable for you. So I hope this technique is beneficial for you. Good luck.